Hello everyone. It has been a while. Glad to be back though. It was requested to do this demo. The synergetics absurdity just has no bounds, so please stay tuned. Synergetics errors are not typo correction. We call this Pythagoras progression. It goes infinitely. Most of these concepts I already argued and demonstrated a year or so ago on my channel under the title SCP, standing for simple cubic packing or primitive cubic packing, and S made by Z, standing for synergetics made by Zubek modules. These two demos are pivotal to dislodge Fuller's credibility in regards to the concentric hierarchy. Let's imagine these squares as cubes from top view like image. So we see these triangles and squares, and let's imagine these as cubes from a top view image. We can clearly see that all the edge lengths, areas and volumes in these squares and conceived cubes obeying a Sundry pattern. All the synergetics cubes are irrational in edge length as well volume. Only the surface areas are rational following Pythagoras' discovery. So we see that we have a whole one, edge 1, surface area of this cube is 6 and volume 1. Here we have a other cube, this is a synergetics cube, square root of 2, surface area of this cube is 12, and the volume is 2.828427125. And then we have so on and so forth. This cube is edge 2, which is 8 times larger than that one. That's my cube. Its volume is 8, surface area is 24, and so on and so forth. Of course, the edge lengths are ratios. They cannot be any different. They cannot be relabeled at will as Fuller have done. They are eternal, since the enclosed area corresponds to an edge length enclosed in it. Therefore, the volume corresponds to the surface area enclosed in it. So a cube of volume 2.828427125, this is this red cube in here, must be simple cubic packing using the same size spheres throughout the whole concentric hierarchy. Now this is a simple cubic packing in here, and two touching sphere is the edge of the tetrahedron, which I'm going to show you in a minute. And of course this is that cube in here, and that's the only way it can be packed, and that, since it's a simple cubic packing, its volume is irrational. Also notice that the diagonals of these spheres are not touching, thus they do not define the edge of the regular tetrahedron. Now here we have a first cube, the very first cube what we have in here. That's this cube, and its diagonal is of course edge of the tetrahedron. That's this diagonal. It's square root of 2, same as this diagonal, which makes up the synergetics cube boundaries. And this cube would be defined by these 4 spheres. That would be for this little tetrahedron in here. That would be for that. Of course, in this particular case, the ping pong balls are really not related to that edge length I wish for, but we clearly see the demonstration what I'm trying to show. So this first cube is defined by 4 spheres defining this tetrahedron, and this is clearly a cubical unit cell of the closed cubic packing.